Imagine a universe where we communicate with machines. We do this using special languages. These languages are called programming languages. They are the bridge between human thought and computer execution. Our journey through the cosmos of programming languages begins in the 19th century. It leads us to the cutting edge of artificial intelligence. We have come a long way from simple binary code. Early pioneers laid the foundation for the digital age. Today, we have powerful languages that shape our world. Join me as we explore the evolution of these languages. We will uncover the stories behind their creation. We will also glimpse the exciting future that lies ahead. From the elegant algorithms of Ada Lovelace to the self-learning capabilities of AI, the evolution of programming languages is a testament to human ingenuity. Each new language has brought us closer to unlocking the full potential of computers. As we continue to push the boundaries of technology, one thing is certain: the language of programming will continue to evolve. This evolution will shape the future. In the early 1800s, a visionary mathematician named Ada Lovelace envisioned a future transformed by computing. Working with Charles Babbage on his analytical engine, a mechanical precursor to the modern computer, Lovelace recognized the machine's potential to go beyond mere calculation. She wrote what is considered the first computer program. This program was an algorithm designed to be processed by a machine. Lovelace's work laid the groundwork for future generations of programmers. She understood that machines could manipulate symbols according to rules. This insight paved the way for the development of software. Her contributions went largely unrecognized during her lifetime. Today, Ada Lovelace is celebrated as a pioneer of computer science. The mid-20th century saw the emergence of the first electronic computers. These early machines were behemoths. They relied on low-level programming languages. These languages used binary code, a system of zeros and ones. This code directly controlled the computer's hardware. Programming these early computers was a laborious task. It required a deep understanding of computer architecture. Despite their limitations, these low-level languages were essential. They allowed humans to communicate with these new machines. These languages were the building blocks. They paved the way for more sophisticated languages to emerge. The evolution of programming languages was about to take a giant leap forward. This leap would make programming accessible to a wider audience. The 1950s witnessed a revolution in the world of programming: the advent of high-level languages. Unlike their low-level counterparts, these languages used English-like words and mathematical expressions. This made programming easier to understand and write. Two languages emerged as dominant forces during this era: Fortran and COBOL. Fortran, short for Formula Translation, was designed for scientific and engineering applications. Its ability to handle complex mathematical calculations made it a favorite among researchers and engineers. COBOL, or Common Business-Oriented Language, was tailored for business data processing. Its focus on data organization and manipulation made it ideal for managing large volumes of information. These high-level languages were a game-changer. They abstracted away much of the complexity of interacting with hardware. This enabled programmers to focus on solving problems. This shift marked a turning point. It ushered in an era of unprecedented innovation in software development. The impact of Fortran and COBOL extended far beyond their initial applications. They became the precursors to many modern programming languages. Section 4. Building blocks of code. The era of structure. As software grew in complexity, a new challenge arose: managing and maintaining large programs. This led to the development of structured programming languages in the 1960s and 70s. These languages emphasized code readability. They introduced concepts such as modularity and control structures. This made it easier to write, debug, and maintain software. ALGOL, short for algorithmic language, was one of the earliest structured programming languages. It introduced concepts like code blocks and structured control flow. These concepts are still widely used in modern programming languages. Pascal, named after the French mathematician Blaise Pascal, further refined these concepts. It became a popular language for teaching programming due to its simplicity and clarity. Perhaps the most influential structured programming language of this era was C, developed at Bell Labs. C combined low-level access to hardware with high-level features for efficient programming. Its versatility and performance made it the language of choice for operating systems and systems programming. Many of today's most popular languages are directly influenced by C. Its legacy continues to shape the landscape of modern programming. The era of structured programming laid a strong foundation. This foundation was for the next major paradigm shift in software development. Section 5. Objects in the Mirror, the Dawn of Object-Oriented Programming. The 1980s and 90s witnessed the rise of Object-Oriented Programming, or OOP. This revolutionary paradigm shifted the focus from procedures to objects, which encapsulated data and behavior. This approach offered a more intuitive and organized way to design and build complex software systems. Two languages spearheaded the OOP revolution: C++ and Java. C++, an extension of the C language, introduced object-oriented features like classes, objects, and inheritance. This enabled programmers to create reusable code modules, improving code organization and reusability. Java, developed by Sun Microsystems, took OOP to the next level with its write once, run anywhere philosophy. Java programs could run on any platform with a Java virtual machine, making it highly portable. The adoption of OOP led to a surge in software development productivity. It enabled the creation of more complex and feature-rich applications. These languages became the foundation for countless software applications. From desktop operating systems to web browsers and mobile apps, OOP languages reshaped the digital landscape. The influence of C++ and Java continues to this day. They remain popular choices for a wide range of applications.